Okay, so lesson 2-2, we are proving lines parallel. So everything you did in that warm-up was showing that angles were congruent or supplementary. Now we are going to take this process and flip-flop it. Okay, so that means that we're going to see if angles are congruent or supplementary to prove that the lines are in fact parallel. So if we take a look at this first one, it says Juan analyzes the diagram to see if line L is parallel to M. His teacher asks if there's enough information to say whether the lines are parallel. So yes, if a transversal intersects two parallel lines and the alternate interior angles are congruent and corresponding angles are congruent, I have both angle relationships here, so the lines are parallel. So does this make sense? In this case, is he correct or incorrect? What do you guys think? Correct, yeah. So he's definitely correct. So we're just going to say, yes, he definitely knows it. Okay. And you just state he made a logical conclusion based on given information. So when we talked about alternate interior angles, alternate exterior angles, same side interior angles, and we talked about corresponding angles, we had the theorem or postulate, right? So if you are ever given parallel lines, that means you are proving angles congruent or supplementary. Now we're going to get into the other part of this where we're going to talk about the converse. And now what we have is we have the converse of corresponding angles theorem, the converse of alternate interior angles theorem, the converse of same side interior angles postulate, and the converse of alternate exterior angles theorem. And what that does is if you're given the angles, then you're proving the lines parallel. So it's a flip-flop, right? Now, if we take a look at this, this says the hypothesis and conclusions are switched, which we learned about in topic 1. So it says if a transversal intersects the lines, so if a transversal intersects the lines, then the corresponding angles are congruent. That's your P and that's your Q. Okay? And this is true from the last lesson. So here's our hypothesis. Here's our conclusion. We know these are parallel because of the two angles are, we know that these are parallel, then the two angles are in fact congruent. So when we write the converse of this, we're going to flip-flop it, just like we did in topic 1. We're going to state if corresponding angles are congruent, then the lines are parallel. And this would work if you're talking about alternate interior angles. If alternate interior angles are congruent, then the lines are parallel. If same side interior angles are supplementary, then the lines are parallel. If alternate exterior angles are congruent, then the lines are parallel. Okay, so we always put the word converse in front of those original theorems and postulates. Questions on that? Everybody still writing? See one person. See, I'm just waiting. 2 people. Flip the page. Oh, wait, do you guys have these? Oh, never mind. They're at the bottom of yours. Sorry, my notes are a little off. Sorry, go back. I didn't know that. So in this case, we're going to talk about the converse theorem. It says if corresponding angles are congruent, then the lines are parallel. Alternate interior angles are supposed to be what? Congruent or supplementary? Close. Which one is it instead? Congruence. Then they are parallel. Alternate exterior angles, congruent or supplementary? 50-50 shot. If alternate interior angles are congruent, what do you think alternate exterior angles are going to be? Congruent. Then they are parallel. All right, if same side interior angles are congruent or supplementary? Supplementary, very good. Then the lines are parallel. And last but not least, if same side exterior angles are supplementary, very good. Then the lines are parallel. Okay? Questions. So these are the converse rules. Converse of corresponding angles theorem. Converse of alternate interior angles theorem. Converse of alternate exterior angles theorem. Same converse of same side interior angles postulate. Converse of same side exterior angles theorem. Okay? All right, we're ready to move on. Anybody still writing? All right, let's take a look at example 1. So it says, if angle 1 is congruent to angle 2, which theorem proves C is parallel to D? So they're saying this is congruent with that. Okay? And we're trying to prove that C is parallel to D. So this is telling me that C and D are the lines in question, with B being my transversal. So this means that since we have the angles congruent and we're proving the parallel lines, what are we going to use here? Are we just going to use that straight theorem or postulate, or are we going to use the converse? Who's got it? Anybody? Do we know? Is it the converse or is it not the converse? All right, if we come back up here, what does it say? Converse theorems are proving what every time? Lines are what? Parallel. So if we're trying to prove these parallel, what are we using? The converse. Yeah, and what kind of angles do we have here? Do we have corresponding? Yeah. Alternate interior. So the theorem is the converse of alternate interior angles theorem. Okay. Questions on that? All right, let's take a look at example 2. The edges of a new sidewalk must be parallel in order to meet accessibility requirements. Concrete is poured between straight strings. How does the inspector know that the edges of the sidewalk are parallel? So what I'm going to do here is I'm going to highlight this. This is our transversal. Here's the parallel line for the sidewalk. And here's the parallel line for the street. So the question here is, what kind of angles is are 1 and 2? They're same side interior. So they need to be what in order for these two to be parallel? Congruent or supplementary?
Supplementary.
They have to be supplementary. All right, so what we're going to state here is angle 1 and angle 2 are same side interior angles. So they should be supplementary to show the street and sidewalk are parallel. Now, here's my question for you guys. Does it kind of make sense that you should have a sidewalk parallel with a street?
Yeah.
Yeah. I mean, we don't want to be walking in traffic, right? That would be weird. That would be very counterintuitive. So do you think this is probably used a lot?
Yeah.
Yeah, it is. It seems strange, but I promise you, it's used a lot in construction. More particularly road and sidewalk construction. Same thing with, you guys ever see those noise canceling walls that are built by subdivisions, right, on busy streets? Same thing. Those have to run parallel with the street in order for the sound to bounce off and not affect the houses. So,
Oh, like the houses next to the highway?
yeah, I'm one of them. I'm getting a wall. Not here, but
Do you hear it a lot? Or no?
my traffic?
Yeah.
Oh, yeah. My backyard is literally like a busy street. But they're expanding it and they're going to put up a wall, I heard. So it'll be quieter soon. But then we'll miss all the drama, like when people get into an accident or something. And our friends always drive by honking, waving hi if we're in the backyard. I'll miss that part, but other than that, I kind of want the wall. And the sidewalk, because I always have kids from Lincoln Way West, like on the street, because there's no sidewalk.
Oh, so like, where do you live in?
I live in New Lenox.
Lenox?
Yeah,
Lenox is nice.
it is. It's just busy. I don't like busy. All right, let's take a look at example 3. It says find the value of x for which m is parallel to n. Okay, so first off, what types of angles do we have here? Who can tell me? Go ahead. Not interior. Yeah, alternate exterior. And alternate exterior angles have to be what? Congruent. So I'm going to take 3x minus 40. I'm going to set that equal to 2x plus 9. And I'm going to solve for x. So I'm going to subtract the 2x from each side. That leaves me with x minus 40 equals 9. And then I'm going to add 40 to each side. So I get x is equal to 49. So what this is telling me is that if I did this correctly and I substitute this in, these two are going to be congruent. Okay? So it said if I want to check that out, I would just substitute it in, make sure it works in case if I feel I made a mistake. Someone tell me, is this going to work for both angles? Hey guys, remind me, when's your test again? Friday. Yes, just double checking.
It's a unit test, right?
Was it?
They're both going to be 107.
All right, they're both going to be 107. So that works. So we know that the value for x, which makes the two lines parallel, is going to be 49. Confirmed, stamped, signed, sealed, delivered. written in stone, if you will. All right, this is just a kind of a recap. If corresponding angles are congruent, then L is parallel to M. If alternate interior angles are congruent, then L is parallel to M. If alternate exterior angles are congruent, then L is parallel to M. If same side interior angles are supplementary, then L is parallel to M. Blech. And then if same side exterior angles are supplementary, L would also be parallel to M. Okay, questions? All right, homework on Realize. Go for it. Let me know if you have any questions. Those of you watching at home, have a great day.